Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we are going to talk about the Solar Dynamics Observatory and its study of our sun. So let's go ahead and get started. So the Solar Dynamics Observatory, or SDO, is a NASA mission designed to study the sun as a dynamic, ever-changing star. Launched on February 11th of 2010, SDO continuously monitors the sun with unprecedented detail, allowing scientists to observe how the solar activity evolves over time. By watching the sun at multiple wavelengths, SDO has revolutionized our understanding of solar behavior and its influence throughout the solar system. Now, SDO was created to answer a fundamental question. How does the sun change, and how do those changes affect Earth and the rest of the solar system? Its goals include understanding the sun's magnetic field, the origins of solar flares and coronal mass ejections, and how energy moves from the solar interior to the outer atmosphere. These processes drive space weather, which can impact satellites, astronauts, power grids, and communication on Earth. Now, the instruments that exist there include the Atmospheric Imaging Assembly, which captures high-resolution images of the sun in multiple wavelengths, revealing different layers of the solar atmosphere. The helioseismic and magnetic imager measures the sun's magnetic field and tracks vibrations on the solar surface, allowing scientists to probe the solar interior. And the Extreme Ultraviolet Variability Experiment measures changes in the sun's ultraviolet output that affect Earth's upper atmosphere. Together, these provide a complete real-time picture of solar activity. The SDO has shown the sun's atmosphere is far more dynamic and structured than previously thought. It has revealed fine-scale magnetic loops, rapidly evolving active regions, and complex interactions between solar magnetic fields. The mission has greatly improved understanding of how solar flares and coronal mass ejections form and evolve. By tracking magnetic energy and buildup, SDO helps scientists better predict space weather events. SDO has also provided new insights into the sun's interior through helioseismology, improving models of how energy and materials move inside stars. Solar activity affects far more than the sun itself. Eruptions can damage satellites, disrupt GPS signals, and pose radiation risks to astronauts. Data from SDO is used in real time by space weather forecasters to monitor solar conditions and improve warning systems. This makes SDO not only a scientific mission, but also a practical one that helps protect modern technology. And let's go ahead and finish up here with a summary. And what we've looked at today, the Solar Dynamics Observatory has transformed the sun from a distant, slowly changing object into a highly active system that can be observed in real time. By continuously watching our nearest star, SDO deepens our understanding of stellar physics and helps us prepare for the sun's influence on our technological society. So that concludes this week's exploration of the solar system on the Solar Dynamics Observatory. We'll be back again next week for another exploration of the solar system video. So until then, have a great day, everyone, and I will see you in class.